This is for people who are absent, who they had like an exciting vacation or something like that. So yeah, you can go up there. Wait, does everyone remember their seats? I think I gave new seats like just before break. Anyone need a reminder? You're sitting over there? Oh, you don't want to be in this half of the thing? Yeah. Okay, then you can move. I don't think we're sitting together. Just new seats. I mean, no, whatever the new seats were.
Outside.
It'll be locked.
Never mind.
Remember where is it?
Oh yeah, Christmas on there?
Yeah. Alright, couple of things. Can I have your AP problem, please?
What?
Guys, don't break the camera.
Like, if you think about it,
Just like try and not.
did I step in something?
This thing right here, my hand.
Skylar, what did I step in?
There's like throw up right outside the door.
I stepped in it?
You guys walked straight through.
If you think about it, it doesn't sound that bad.
AP problems, AP problems, AP problems, AP problems.
Is Amanda here today? No, she is. Yes.
AP problems.
Yo, Matt.
AP problems. You ready?
Got a really well scratched up.
AP problems, AP problems, AP problems, AP problems. Do I have everybody's AP problems? Everybody? Going once. Going twice. If I do not have your AP problems now, it's like not good for you. Okay, good. So,
here's another one.
period 4, welcome back. How was your spring break? Rob, why did it suck?
I miss math so much.
Oh, that's a good reason. What's this? Oh, who's not here?
Ooh, it's red on your face, Jason.
Alright, no Amanda, no Jesse, no Sid. That means it is a good reason that we are taping class. So, hello Amanda, Sid, and Mel and Chop. Yeah, it's already taping.
Taping class.
We have taping class like 4 minutes. Did anybody do anything exciting over spring break?
Wait, why are you
Yeah, it's recording.
But then they
I
go
don't know.
out our private.
Yeah, it's not private. You're about to tell the whole time. Yeah, if you have something very private, it's not a good time to share.
I slept in the same bed as Eric over the weekend.
Whoa, that's.
Wait, actually. No, I would.
Anyone doing anything exciting? Yeah, what you?
I had this big party of a lot of food.
Big party with a lot of food. Lucy, did you do anything exciting? Who left the state of Maryland?
I went to Virginia.
Okay, yeah. Where'd you go? And by you?
That counts too.
Maybe? I'm willing to share. One person? Just one for Dan, what'd you do? Where? Delaware? Oh. Delaware. Alright, that's all we got?
Virginia.
Where'd you go?
Rhode Island.
North Carolina, that's pretty far. Where'd you go to North Carolina?
Close to Tennessee.
Close to Tennessee, oh yeah.
Order each one?
What'd you do for break?
I went to Mexico.
Oh, you got a little fan. A little crusty. Okay, good. So here we are on our kind of like fake half week. Wallops is coming up soon. Are these people in this class? Alex Newman, Christine?
Yeah. Christine's in this class.
Alex Newman's in this period?
Yeah.
Oh, yes. So there's actually like a lot of people not here today. All right. Wallops is Wednesday through Friday. We will have class Wednesday morning. Danny Wrong, you're gonna like go to some room somewhere. It's already been arranged, and you're just gonna sit and chill. There is a. Well, does anyone have any questions about Wallops? Like, not about math.
Bring more pounds.
No, just like ask me a Wallops. Yeah, bring lots of. Danny Ron, what should we tell them? Bring lots of
shoes and pants.
Yeah, bring lots of shoes and pants and t-shirts.
Wait, Mr. Are you going?
Yes, I'm going.
You know who you're chaperoning?
Oh, I can't tell you, that's a secret. But yes, I do. What else?
What about the math packets?
Oh yeah, so you want to just cut right to the math. Okay, so there is in fact a Wallops math packet. This is an annual Wallops tradition. It is a great math packet. It is simply, I'm passing it out now so that you will have it in your possession. It is just a bunch of anti-differentiation problems. So it is kind of mindless, which makes it a really good thing to work on during Wallops because you can sort of just be doing other things and just like eating and talking to someone and you can just kind of like just be sitting around mindlessly doing a bunch of anti-differentiations. However, though mindless, I'm not saying that it's easy. It's kind of hard. So that makes it doubly appropriate for Wallops because you have friends all around you who will who can maybe help you. So you stare at a problem for like 3 minutes, you're like, what should I do? And then the person next to you is like, dude, just let you be, root X. You're like, oh, okay, I got this down. So that's good. So, ideally you work on it a little bit on the bus, you work on it here and there, you got a free half hour, nothing else is going on, check out the Wallops packet, bam, 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 do another 6 or 7 problems, all done by the time you leave Wallops, and then you have no homework that weekend. We have class, I think, the Monday after Wallops? Yeah. Those people watching this at home, you need to pick one of these up, remind me. What else was I going to say about this? Oh yeah, bio. Google has essentially just canceled bio for the next 2 days, and I think you guys are just doing nothing. Are you aware of this already?
Yeah.
Yes. So, if you have her 8th, then that's that. But if you have her either any one of the other 3 periods, then you basically don't have class for today and tomorrow. So, one thing you could do is sit and work on your Wallops packet. Potentially you could maybe have the whole thing done before you even went to Wallops, though that would not be in the spirit of things. Any questions about that? Good. Yes.
I like sports stuff. Like,
can we bring a basketball? Oh yeah. You can bring a basketball. You can bring frisbees. You can bring all kinds of things. I have a kite. I also purchased a slip and slide for $9 over the weekend. I might bring that. What else? Oh, I also have something. I have something to sell. Does anybody want to buy a? Does anyone want to buy would anyone like to buy a headlamp? These are high quality headlamps. They come better than a flashlight. $10 only. If so, please see me after class. Because I bought a 3-pack and I have no idea why I bought a 3-pack a long time ago. All right. So let's do some math now. And here is the math that we are going to do. You had some homework from the book, which I thought was relatively easier than some of the other problems. Can you take that out? And can we go over a couple of these? And actually, while we go over a couple of these, let's put some of the other problems from the packet on the board. So this is from the packet. Let's do, I know we did most of these class already. Could I have 2, 4, 6, could I have 8? Ah! I just walked into the camera. That's embarrassing. Sorry. Can I have 8 people get up there and do those 8 problems that we were working on from the anti-differentiation by substitution package? Don't all jump up at once. Yeah, good. Get up there, lead the way. While they do that, let's go over some textbook problems. Wilson, which problems from the textbook should we go over?
63.
63. Oh yeah, that's a good one.
Okay, Alex, I got one thing.
What else? No other ones.
Wait,
Were these kind of easy-er from the textbook?
yeah.
I thought they were good.
Right,
It was supposed to be one more.
35.
35. Yeah, I can do that. Anthony Lee.
71.
71. All right, that is a perfect selection. Let's do those three right now. 35 said. 35 said dy dx is 4x plus 4x over root 16 minus x squared. And they want to know what y is. Well, y, if this is the derivative, then y is going to be just the antiderivative of that. And this, the first thing we should notice about this is that, well, let's just split it up, because whenever you are dealing with a antidifferentiation problem, it pays to split it up into as small pieces as possible. So this is really like 4 x dx plus 4 x over root 16 minus x squared. And, well, this guy is easily doable, because that's just x squared over 2. So this becomes 2x squared. Boom, boom. And then this guy, well, for this I'm going to use some kind of a u sub. So by now I think you're probably getting good at this. You see, like, all right, well, if I let u be 16 minus x squared, du is then negative 2x dx. And then there's almost a negative 2 in there, except there isn't quite really. So I put in the negative 2, and I undo the damage with a negative 1/2. At least that's how I do it. Following this, everyone, basically? All right. So then when I simplify this, it becomes negative 2 antiderivative. Well, negative 2x dx is just my du, and then this is just over root u. So really, this is 2x squared minus 2 antiderivative u to the negative 1/2. Bless you. And so now, finally, I antidifferentiate it after putting it in this form. It's going to be 1/2. The 2, 1 over 1/2 is 2, so that's minus 4 u to the 1/2 plus. And so my final answer is 2x squared minus 4 root 16 minus x squared plus 2. That's it. That was number 35. 63, I actually messed up this. Anyone have any questions on this? I think I did that right. Is that the right answer? Good. 63 was antiderivative of cotan squared. All right, well, it's not immediately obvious what to do here. I don't have any, there's no function I know whose derivative is cotan squared. But what can I do?
Use your trigonometric identity.
Yes, use the Pythagorean trigonometric identities and simply rewrite cotan as, let's see, cotan squared x plus 1 is cosecant. So cotan squared is in fact cosecant squared x minus 1. Ah, that is
I can't see
good.
anything.
Ron, you getting this all?
Yeah, but I don't know if I should zoom in. It looks really pretty.
No, don't zoom in. It'll be fine.
Okay.
Let me get a better marker then.
It's good.
Then this can just be split up into two pieces. Antiderivative cosecant squared x minus just dx minus just, well, I probably don't even need to do this. Antiderivative cosecant squared, this is just going to be negative cotan. So I end up with negative cotan x minus 1 plus c. Do you guys follow that?
Minus x.
Oh crap, minus x.
There's a 1 in that.
Yep. Thank you. Well, lots of coughing going on everywhere. 71. 71 is just a little bit annoying. This is antiderivative e to the sine pi x cosine pi x dx. So, while experience by this point is telling me that I should always try to let u be the inner function. So if I let u be sine pi x, then du is cosine pi x back inside pi. And that's exactly what I have, except I'm missing a pi. So I put in a pi and I undo the damage with a 1 over pi. And so what I have is 1 over pi e to the u du. So that's pretty much just it. So my final answer is going to be 1 over pi, any derivative of e to the u is equal to u. So this is e to the sine pi x plus c. Everybody good with this? Everyone think are good? Basically? Okay, good. Can I have all these homeworks like right here? Ron, can you put the camera around? We're going to go over this. Just page 340. Just page 340, yeah. Okay, then please take out your antidifferentiation by method of substitution packet, that thing we were working on before break. We did a lot of you got pretty far actually in class, so some of these we may have done already. Let's just go over them really fast. Number 10, antiderivative ln x over x. Well, you realize if you let u be ln x, then du is just 1 over x dx. It works out perfectly, and this is really just a u du problem, so we get 1/2 u squared plus c. This is perfect. Number 11 is actually very similar. Now, if I let u be ln x, du is still 1 over x dx, and now it's just a du over root u problem. So I like how this person rewrote it, just so as to be careful, as u to the negative 1/2, and so then that's just 2 root u plus c, so I get 2 root ln x plus c. Any questions? All right, 12, cosine x times the cosine of the sine of x. Well, again, pretty much most of the time you just let u be the inner function. So the u be sine, du is cosine. This person likes to do it the solve for dx way, that's okay. So dx is going to be du over cosine x. So stick that in, zoom zoom, cancel cancel. This is just any derivative of cosine u du, sine u plus c. So it ends up being sine of the sine of x plus c. Any questions? All right, 13, the original problem was any derivative of e to the x over e to the x plus 1. So there's a lot of kind of ideas you might have had that sort of end up not working. But eventually you realize, oh hey, if I just let the bottom be u, then du dx is e to the x. So again, this person likes to solve for dx. But basically, yeah, okay, so dx is du over e to the x, and that's kind of what I have. So you put that in and you cancel it, and this is really just du over u, and that's ln absolute value u plus c. So we get ln of e to the x plus 1 plus c. 14, yeah, again, you have to know all your derivative rules. If you know the derivative of arctan is 1 over 1 plus x squared, then this should be staring you in the face. If I let u be arctan, then du is sitting right there, and so this is really just u du. Boom, boom. 15, there's a couple different ways to do this. I think this person just kind of did it. Good. Fine with that. All right, 16. Do we even need to go over 16? I thought that was also kind of, not easy, but again, since secant squared is the derivative of tan, if I let u be tan, then I'm in a u, I don't like this way, but whatever. Then you end up with then you have a u squared du situation, and so bam, 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 bam. Lastly, 17. Let's look at this. This requires a little bit more care. So some complicated stuff going on. If you let u be x to the 3/2 plus 1, then the derivative of that is going to be 3/2 x to the 1/2 dx. So then she says, well, I can rewrite this therefore, let's see, the 3/2, basically she puts the 3/2 in and takes out a 2/3. So this is 2/3 10 over u squared du. And so it's actually not following all the work exactly. I could just do the just Anna, right? Did you just do the rest in your head? Yeah. Okay. She just did the rest in her head. So she took out the 10, anti-differentiated u to the negative 2, which is 1 over u to the negative 1. There's a negative, so okay, I would show more work, but that is the correct answer. Questions on that? Whoa. Okay, good. Rob, turn the camera again. Actually, Rob, have you been panning?
Yeah.
Are you like doing a good job? Is that visible over there, that number 17?
Yeah.
Or is it cut off halfway through the board?
No, I can see it.
Everything's good?
Yeah.
Okay, good.
Well, you again.
Okay. Now, let's do more. I think I asked you to do through number 19, and I thought that number 19 was hard. So let's do number 19 now, and then we're going to continue to work on this packet. Basically, that's just what we're going to do for the rest of class. So, number 19 was antiderivative x cubed plus 1 over x squared plus 4 dx. Okay, the first thing is, and I hope you're kind of getting a sense of this by now, it is always better to split up the thing you're anti-differentiating into as many different pieces as possible. The more I can split it up into different pieces and attack those pieces one at a time, the easier everything is going to be. So a problem like this, anytime you have a rational function and the degree of the numerator is greater than or equal to the degree of the denominator, you should do polynomial long division. Because doing polynomial long division will enable you to split it up. So if you have not done so already, please do polynomial long division right now on this problem, and thus split it up into little more manageable pieces. And you've got to kind of write small with this problem. And that's basically all you can do, right? So, alright, I have successfully rewritten this as x plus, you got to kind of be careful with your negatives also, over x squared plus 4 dx. Everybody with me? Wilson?
Yeah.
Yeah. Okay, well that is some progress. I consider it progress because, well, I know how to anti-differentiate x, so that's like good. I still don't know what to do with the rest of this, bless you. I don't know what to do with this negative 4x plus 1. What do I really wish that negative 4x plus 1 was? What would be really great about that?
Negative 4x.
Yeah, I really wish, Ari says, I really wish that 1 just like wasn't there.
Yeah.
Because if that 1 wasn't there, then I know how to do this. Then I would just let u be the bottom, and then du would be like 2x, right? And that would be fine. Okay, but it is there. So what can I do? Split it up. Just keep splitting it up. Yeah, split it up more. So this becomes antiderivative x dx minus 4 antiderivative x over x squared plus 4 dx, and then plus just a 1 over x squared plus 4 dx. So again, keep splitting it up into as many little pieces as possible. Okay. Well, at least now I really have just 3 problems I have to do. Let's just kind of do them one at a time, I guess, right? I'm going to do the middle one. Stefan, stop doing that. Good. So I got that far. Someone check my work. Looking good? Okay, so I'm 2/3 done with the problem. I just have to figure out how to anti-differentiate 1 over x squared plus 4. Any thoughts on that? Sage has a thought. How about everyone else? Actually, how about Sage? Sage, what's your thought? Yeah, Sage says it's kind of like arctan. Let's play how is it like arctan and how is it not like arctan. Sage, how is it like arctan?
Well, you have the x squared at the bottom.
Yeah. Yeah, arctan is like 1 over x squared plus 1. How is it not like arctan? There's a 4 there. Okay, so I need that 4 to not be a 4 anymore. I need that 4 to be a 1. Now, how can I make that 4 1? Just because I wanted to. Just the magic. Yeah, you use the magic of the algebra to make that 4 not a 4 anymore, but instead to make it a 1. Someone got this going kind of? Yes. There are many different ways to do this, but I like to do it this way, which I think is helpful to people who are beginners. So I just factor out a 4 from this expression. And if I factor out a 4, this becomes x squared over 4, and now this is magically just a 1. Someone see what's going on? It's pretty good. Yeah, it is pretty good. So now, now I can continue to make this look more and more like arctan. I can pull out the 4. That's really a 1/4 dx over, rewrite x squared over 4 as, yeah, x over 2 quantity squared plus 1. And now it's looking a lot like arctan. I'm just a u sub away from being able to apply the arctan formula. It's all making sense. Skylar? Yeah, so now I just let u be x over 2. And if u is x over 2, then what's du? Okay, it's 1/2 dx. So I need a 1/2 in here, so I stick in the 1/2, undo the damage with a 2. And after this kind of algebra magic, I have rewritten this problem as 1/2 antiderivative du over u squared plus 1. And now that looks a lot like arctan. In fact, it pretty much just like it is. Is it making sense? Wilson, you good? Yeah. So final answer, 1/2 arctan u. In other words, arctan x over 2 plus c. And then all this other stuff too. Okay, that was pretty hard. Moral of the story, split things up in lots of little pieces, look for patterns. Alright, that was number 19. That was pretty hard. We have, here's what we're going to do the rest of the period. 20, 22, 23, 25, 27, 29, and 31. Alright, go. Some of these you probably won't be able to figure out on your own. We have exactly, oh crap, we have only 16 minutes. Alright, go fast. Okay. Really late on the time.
Wait, do you want me to keep recording?
It's like, what's it called?
Wait, Mr. Rose, do you want me to keep recording? No.
What?
Do you want me to keep recording?
Yeah, keep recording.
Cosine.
Yeah?
Yeah.
Let's factor out a 4.
And also condensation is
4 times 1/4 minus x squared. And that's just like, one, right, that's like 1/2.
They did a lot of these.
1 over and I minus x squared.
Alright.
Sage is just an overachiever.
Did you figure that out?
I'm just going to the one with the negative.
Is it negative? Yeah, because secant positive and sine. Sine. Okay. So in that case, it's like yeah. 1 over that. All right.
You can make the 4x squared 2x quantity squared.
Alright, so you could stare at this for an hour and have no idea what to do, and then suddenly you realize what to do. What should we do? What does this kind of look like? It kind of looks like arcsine. Yes, kind of a lot looks like arcsine, right? Because what is the derivative of arcsine? And yes, you're expected to just know these by this point. It's that. So, yeah. They're like almost identical, right?
Factor out of 4.
Well, no, in this case you don't even have to factor out of 4.
2x.
You guys got this?
Oh yeah, you just
Yeah.
do 4x.
You just write it as, you just rethink of it or rewrite it as quantity 2x squared. And then if you just let u be 2x, du 2dx. Chris, you got this?
Yeah.
Some of you like to do some of these things in your head. Personally, I don't. I go down to the bitter end. I only anti-differentiate when it is of like a basic form like that. So I know that this is 1/2. Okay, how are we feeling about this? Good. How about 22? We're doing them. No, we're doing them. You try to stay ahead of me. Okay, that's good. I'll give you a minute.
Okay, let's
Yeah, really safe. What you gonna do?
what is our secant? 1 over x.
We're getting 22 right now.
Then it would be root x squared minus 1. Yeah, that should be enough.
Try 22. 22. 22. Everyone.
So that's
22 takes a while.
I'm sure that's right.
what is arc? Oh, wait, arc secant. Are you doing 22?
Yeah.
X squared minus 1. Yeah, okay.
Divided by 16.
Divided by 16, yeah. And then you can just actually end up factoring 1x, take out 16.
Alright, you're not going to get very far in number 22 unless you realize one very important thing. What does this look like?